Hello, welcome to another problem session. Today we are going to talk about static friction. So this is a very standard problem, and we will illustrate a couple of ideas that go with this kind of problems. So first is what the question is. The question is about this block. It's on a table and is being pushed, and this block is not sliding. When that happens, you can see that this block, this surface here of contact is not changing. It's the same. It remains the same. So this surface must be, there's a force along the surface that's matching the force, the push, the force of push. So that's the overall idea. And the question is, says that if this force gets bigger than this, then this will start to slide. If this F is greater than 25 Newton. So it seems like whatever the friction is, its maximum is only able to match up to 25 Newton of this force. And that's what it's called. This friction that must be happening here is a max. So if I say friction F is at the max, friction is at the max if F is 25 Newton. So that's what this means. And you have to know that this max of the friction is actually connected with a normal. So another bit of knowledge that you need from somewhere else is when the gravity is pulling it down. So this is gravity is pointed down, is gravity is pushing, and the part of this force is also pushing down because it's really not horizontal, it's slanted, so there's some vertical part of it pushing down. So this weight and some of this force is pushing down, and that's being supported by a normal force. And when you are at the max, then the normal force, you can write this magnitude as a proportional normal force. So this is definition that you need to know, that if I'm at the max, not at other friction, but when I'm at the max, then I can write this as some coefficient of static friction times the normal. And this is one way to define this. So whatever the max friction is possible can be written as some ratio or a proportion of the normal force. And that proportional constant is a coefficient of static friction. This much you have to know before you do this problem. Okay, so now to the problem. We're supposed to get the magnitudes. We already know the directions. Directions are already known, and the static force is that way. So the directions are already known. We only need to know the magnitudes of this. And then the last question is, what's the static friction? So if I can figure these guys out, this one will be, B will be just straight from this equation. So finding this and this is the task. Okay, So the step 1 is we already gone through identify all the forces. Step 2 in these problems is, so we've done that there's a force F, there's a Fn, there's FF, and then there's a weight. So we got 4 forces and they're acting in different directions. Step 2 is draw a simple free body diagram. It's called free body diagram. What is that? Is make this picture a little simpler. So it will just have forces, and all the forces will be coming out from the same point. So we'll draw F, and normal will be like that, and this force is pointed into it, but we draw as if coming out like that. So if this was a 30 degrees here, so this will be 30 degrees, so this will be 30 degrees. So this is the F was 25, this is the F is 25 Newton, and this weight is mg, which if you want to write down 1.5 kilogram times 10 will be 15 newtons. Okay, so we'll use g equals to 10 meter per second square for simplicity. Okay. Now you can see that the only 2 unknowns, and the next step is step 3 will be coordinates, your choice. So here clearly we can take this as x-axis and this as a y-axis, positive y-axis, and place this at origin, and then find the components of these forces and put that in equation of motion. Step 4 is, since acceleration is equal to 0, F net equal to 0. So this just means go net along the x equal to 0 and F net along y equal to 0. So these are 2 equations we will get, and from there we can get both of them. Okay, so now step 5 is just want to say that this problem is coming from this website. That's my website, and you can have more resources there. So step 5 is implementing. You can see that if I go along the x-axis, I have this cosine 30 degrees, 25 cosine 30 degrees, 25 cosine 30 degrees, and minus FF. This is negative. This magnitude is positive, so cannot minus FF. And there's nothing else along the x-axis, that's equal to 0. Along the y-axis I have Fn, and weight all is negative components, so that's minus 15. And coming from here is this part for F will be sine 30 degrees. It is the opposite. So minus 25 sine 30 degrees equal to 0. So this can be solved for FF, and this can be solved for Fn. This is 15 minus sine 30 is half, and cosine 30 is square root 3 over 2, and this is 25 times half. So this is 15 plus minus 12 point. This is minus, this is plus, actually should be plus 12.5 phi is 37.5 Newton, and this would be 12.5 times square root of 3 newtons. So we can actually use a calculator to get the complete this product, which approximately 12.5 times 1.73 Newton. 1.73 Newton. Let me see. Let me pause and give the answer. Okay, so I went ahead and completed this calculation, and so this is the friction force, and this is the normal force. That's part A. I should be careful in terms of labeling them, so I put max here and max here. So this Fs, this should have been FF max. That's what we have when we have 25 Newton. And if we complete all of that, then we have A is done. For B, we just take the ratio of the max friction to Fn, and I find 0.58. So let's recap just before we go. So in many of this problem, we are trying to use this logic here. This is the main logic. We're driving towards that, use of that logic. This is the law, or second law of motion. And to use that, there are several steps. First, you have to know that this definition of that at the max, we define the static friction coefficient, and when the static friction is the max. This kind of problem involves very discrete steps. You have to identify the forces. Then it's really very helpful to draw a free body diagram. And in the free body diagram, all the forces are coming out from the same point. What this does is placing the coordinates and working out the components much more easier. Okay, it becomes easier task, considerably easier task if you do the free body diagram. Of course, it's not necessary to do this, but it is very helpful. Once you've done that, then you choose the coordinates and then work out the components. And so you have two equations to work out: equation 1 along x, equation 2 along y. And when you work out, you get two simultaneous equations usually to solve. And when you solve them, normally that addresses the problem. Okay, so this should be a very much into your skill set, because when we're going to address more complicated problems, it will be assumed that you already know this stuff, and you have to practice a lot to get internalize these steps. So try to do a whole bunch more problems. Okay, see you next video.